Using exactly the same condition, balancing condition, we have just taken a meter bridge here. What is this meter bridge and what for it is being used? Two things we have to remember. One, to calculate unknown values of resistances. Using meter bridge, unknown values of resistances you can determine. And what is the second one? The second use of this one is you can determine resistivity of a wire. That is of course a conductor. Resistivity is also called a specific resistance. So here we people are taking up a conducting wire. Whatever is the material of that wire, for that material you can determine the resistivity part of it. When you just take this meter bridge, how this looks like? You will be finding on a wooden base, 3 metal strips are mounted this way. You can understand directly. On each strip, 3 connecting screws we will be finding, and we used to have a meter long wire connected in between these two. This now is connected across a cell and a cell, this one key like this. This is what is called as primary circuit. This primary circuit. And this is what we call it as left gap of meter bridge, and this one is the right gap. In the left gap, we connect a resistance box. In the right gap, we connect that wire of which the resistance is to be determined. From this particular screw or connecting terminal, we connect a high resistance and a galvanometer, and there from it's connected to a jockey like this. And in fact, this circuit we call it as a secondary circuit. Now what one has to understand from this one is, if unknown resistance if you take it as R1 and known resistance if you take it as R, you can determine this value of R1 by the same application of balancing condition of Wheatstone bridge. So in the resistance box, when we apply some known resistance, the balance length of course we used to measure as L1 here, and the remaining length of course when I consider it as L2, the sum of these two values L1 and L2 must be equal to 1 meter of this wire. That in the sense the total length of this wire is exactly a meter. If L1 comes to be 40 centimeter, L2 automatically will be 60 centimeter, we know that. Now what is the principle of this particular Wheatstone bridge? Same principle we have to apply here. Same condition is to be taken up there. How just do you look at R by R1, that is this known resistance by unknown value, that now must be equal to L1 by L2. This balance length whatever we are obtaining it as L1 and this one as L2, this R by R1 is equal to L1 by L2. In fact, this is the equation by means of which this unknown resistance R1 we can calculate using meter bridge. But one thing one should understand, meter bridge is a simplified form of Wheatstone bridge. There is absolutely no difference between these two. We are taking up lengths over here. Why we are taking instead of resistances the lengths, like theoretically speaking, resistance is directly proportional to length of the conducting material, conducting wire. Therefore, we can say R by R1 is equal to L1 by L2, where L1 comes to be the balancing length in meter bridge. So, this is one more application of this Wheatstone bridge in the form of meter bridge you people have to remember. So, this is one.